Hello guys, welcome to your channel which is SciEngineers. This is Sushan. We have been uploading videos for the Mhtcet section for the mathematics, and we have over 50 plus videos in our playlist for Mhtcet. We will be soon starting with the topics of physics also. So to get them on a regular basis, please do like our videos, do share our videos, and do subscribe to our channel. Also hit the bell icon to never miss a notification from us. So today's video is going to be dependent on the topic of differential equation. So do stay safe and keep watching, keep learning, and happy learning. So let's go. So we are discussing these two sums which were asked in the previous video. So the first question was we need to find the area between these two curves, that is basically y is equal to 2x minus x square and the x-axis. As we know, on the x-axis we have y is equal to 0. So let us just substitute y is equal to 0. So we'll be getting the point of contact, or the point where this particular curve is meeting the x-axis. So if I substitute y is equal to 0, I'll be getting this as 2x minus x square is 0. That means either x is 0 or I will be getting x as 2. So these are the points where basically this curve is meeting the x-axis. So that's nothing but x is equal to 0. Since we have y is equal to 0 at this point, so it's 0 comma 0, and y 0 in this point also it is 2 comma 0. So these are the 2 points where this particular curve is meeting. So the integration is going to be between 0 to 2 of y dx. So y is nothing but 2x minus x square dx. So finding the integration for this, we have 2x, which is 2x square by 2, so that's x square, minus x square becomes x cube by 3. So that's 0 to 2. 2 is substituted, so that becomes 4, minus this is 8 by 3. So if I solve this, it becomes 4 by 3. So that's nothing but your option B. Moving ahead to the next one, we have the area bounded by x square plus y square is equal to 8 and y square is equal to 2x. So you know x square plus y square is nothing but a circle which is at the center is at origin, and the radius is nothing but root of 8, which is 2 root 2. So we have a circle with center at origin and the radius is 2 root 2. That means this point is nothing but 2 root 2 comma 0. And y square is equal to 2x is another curve which is nothing but your parabola. So this is that parabola. So for this I need to find this point of intersection. So that point of intersection we need to just substitute y square in this. So I'll be getting x square plus 2x, let's take the 8 on the other side, is equal to 0. So we need to solve this particular quadratic equation. So we can see that it is nothing but 4x minus 2x. So we are just making this as 4x minus 2x, and from this if I solve, I'll be getting this as x plus 4 as one of the factor and x minus 2 as the other factor. So I'll be getting x as minus 4 and x as 2. Now I need to substitute these values in the parabola. So if I substitute x as minus 4 in this, I'll be getting y square is equal to minus 8. But I cannot get a squared value as negative, so this particular point is basically non-existent. Going to this next one, it is x is equal to 2. If I substitute over here, I'll be getting y square is equal to 4. So that means y is equal to plus minus 2. So basically I'm getting 2 points, that is 2 comma 2 and 2 comma minus 2. So that's why this point is 2 comma 2 and this particular point is 2 comma minus 2. I need to find the area between this. So you can see that these area, if I split it up into half, it's symmetrical. So we can just need to find this particular portion. And if I break this down, I need to find these areas together. So the area is going to be twice the integration of from this point, that is 0 comma 0. So x is 0 over here, and we are following this particular curve, that is nothing but the parabola. So it is 0 to 2 and it's nothing but root 2 root x. I'll be following this particular curve, that is nothing but this circle. So that is nothing but root of 8 minus x square. So if I just solve this, I'll be getting 2 times root 2 goes outside, x square root of x becomes x raised to 3 by 2 upon 3 by 2 with the limit 0 to 2 plus this is nothing but root of a square minus x square form. So that becomes nothing but x by 2. So x by 2 root of a square minus x square plus a square by 2. So a square is nothing but 8 by 2 into sine inverse of x by a. So x by a is nothing but 2 root 2. And the limit is from 2 to 2 root 2. So if I solve this thing, I'll be getting the answer as 2 pi plus 4 by 3. So that's nothing but your options. So starting with the first question of your differential equation topic, in which the first 2 questions are going to be related to the order and degree of a differential equation. Now these are more the popular type of questions in the differential equation topic, and the differential equation itself is a very high weightage topic, so don't leave this particular topic. So let's go for the understanding of the order and the degree. So first of all, the order means basically the highest derivative which has been taken in the particular differential equation, and degree is nothing but the degree to the highest derivative term. So whenever you're finding the order is always nothing but the highest derivative, that is nothing but the double derivative. So you can see the double derivative is nothing but the order, that is basically order is 2. Now when you want to find the degree of this, you have to always see that the powers are not in the ratio format, or neither they should be in the negative value. So if I want to remove this ratio, what I have to do is I have to take raised to 4 on both sides, and since I have to remove this also, I have to take raised to 3 on both sides. So if I'm taking raised to 3 and raised to 4, that means basically I'm going to be taking raised to 12 on both sides. So if I multiply the degree by 12, this becomes 4 and this gets cancelled, and this becomes 3, and that's 3, 9. So we need not bother about this. The only main concern is this. So you can see that the degree raised to the highest derivative term is 4. So the degree of the differential equation is 4. So that's your option A. Moving on to the next one, we have the same question. The differential equation is given to us and we need to find the order and the degree. Now, since you can see that this term is basically in the denominator, it has a degree which is negative. To remove the degree, negative degree, we need to multiply it throughout. So we'll be multiplying by dy by dx. So if I'm multiplying by dy by dx, this becomes the whole square, and we'll be having dy by dx term on this side also. So ignoring this. Now let us find the order. So order, you can see it's nothing but only a single derivative has been taken. There is no double derivative or triple derivative. So order is 1. And we need to see the degree. So you can see there is the highest degree, because there are 2 differential terms with the same order. We have to check the highest degree. So that's 2. So that's why again 1, 2 is the answer, that is A. Moving on to the next type of questions. The question is the solution of a differential equation. So they have given an equation, differential equation, and the solution is also being provided. And they are asking us what is the value of C1. So C1 is, you can see, it is this particular term. So when the solution of the differential equation is given, what you try to do is you basically find the derivative. You just check this equation. You can see it's the double derivative which is present over there. So you take the derivative of y 2 times. So my y is c1 e raised to minus 2x plus c2x plus c3. So if I take the first derivative, you can see dy by dx becomes c1 as it is, e raised to minus 2x is minus 2 e raised to minus 2x plus C2 as it is x derivative is 1 and C3, the derivative of C3 becomes 0. If I take the second derivative, that is d square y by dx square, I'll be getting this as 2 minus 2c1 as it is, and the minus 2 because e raised to minus 2x will again have minus 2 e raised to minus 2x, so this becomes 4c1 e raised to minus 2x, and c2 the derivative is going to be 0. So if I now compare this and the given equation, that is the differential equation, you have 4c1, that is your 4c1 should be equal to 1 because the coefficient is 1 over here. So c1 should have the value 1 by 4. So that's your option B. Moving ahead with the next type of questions, the next type is let f denote a family of ellipse. So this is an ellipse which is given whose center is at origin and its major axis is the y-axis. So just drawing the diagrammatical representation. So this is my ellipse, and family of ellipse means it's going to be these type of ellipse which it is talking about. Now we know that the equation of the ellipse is x square upon a square plus y square upon b square is equal to 1. Now since they are taking that talking about the y-axis being the major axis, that means it's simply telling us that b is greater than a. So in this case there is no change in the equation as such, we will keep it as it is. So now let us now take the derivative of this. You can see that there are two arbitrary constants because a and b, if I take different values of a and b, then I will be having different ellipse accordingly. So if I take the first derivative, I will be getting this as 2x upon a square plus 2y upon b square dy by dx is equal to 0. So we have taken the first derivative. Since we have two arbitrary constants, we need to find the second derivative also. Now directly if I go and find the derivative, that's the second derivative, I will be not able to eliminate the arbitrary constants because in the differential equation I do not need the arbitrary constants. So what I will do is I will be taking the arbitrary constants on one side and then I will be finding the derivative. So let us try to bring the arbitrary constants on one side. So when you are taking the arbitrary constants on one side, you will be getting this as minus b square by a square is equal to all the other variables and the differential terms on the other side. So if I now take the derivative, since this is a constant, it becomes 0. So I have got rid of the arbitrary constants which is required. So if I now find the derivative, this becomes 0. And let us now consider this terms because it's basically having the multiplication part to it and also a division to it. So what we will consider this as being y as one term, 1 by x as the second term, and dy by dx as the third term. So it will be of the form UVW. So the differential will be easier to calculate. So let's find the first derivative, that is of y. So it's nothing but dy by dx. We already have one term of dy by dx. So it becomes dy by dx the whole square. Then next term is 1 by x. We know the derivative of 1 by x is minus 1 by x square. And the remaining, that is y dy by dx. Next, y and x remains as it is, and dy by dx derivative, which becomes a double derivative. So it is becoming plus y by x d square y by dx square. So in this, now what I will be doing is I will be multiplying throughout by x square. So if I am multiplying throughout by x square, this x square gets cancelled out. This goes up like xy, we get 1xy. And here we are going to be getting x. So if I take, so this is nothing but xy. So xy d square y by dx square. And we have this as x dy by dx the whole square minus y dy by dx the whole square. So you can see this term is here. If we take dy by dx common, I will be getting that, and inside the bracket I will be getting x dy by dx minus y, which is present over here. So that's nothing but your option C. So we need to find the differential equation of a family of straight line whose slope is equal to the y-intercept. So let us try to understand what it is telling us. So if I have any line y is equal to mx plus c, this is the general equation of line. It is telling us that the slope, which is m, is equal to the y-intercept. So we know that the c is in the y-intercept. So basically my m is nothing but c. So what we can do is we can take the c common and x plus 1. Since there is only one arbitrary constant, we need to find the derivative only once. Before taking the derivative, what we can do is simply we can take x plus 1 on the other side. So we have y upon x plus 1 is equal to c. So if I find the derivative of this becomes simply, the derivative of c becomes 0. So this is nothing but now y by x. So u by v rule. So u by v rule, it's nothing but y derivative is dy by dx into the denominator as it is, minus the derivative of x plus 1, which is 1, and y as it is. This thing is, on the other side we can see it is equal to c, which is nothing but constant. Derivative of that becomes 0. So the denominator, which was nothing but the denominator square, x plus 1 the whole square, after the derivative we can take it on the other side and we get this as the equation. So you can see it's nothing but option A. Moving on to the next type of questions, wherein the differential equation is given to you and you need to find the solution for it. So in this case, it is asking you the particular solution. So whenever a particular solution is given, in that case, they will be giving you certain points. Now it becomes easier to solve these type of questions because what you can simply do is you can see whether these values are satisfying the equation, that is the options which are given to you. So let us see that if I substitute y is 1 and x is 0 in the equations, whether I am getting the equation satisfied or not. This is only applicable if they are asking you for a particular solution. So if I substitute y is 1 and x is 0 in this, you can see tan inverse 1, which is pi by 4, and tan inverse of e raised to 0. E raised to 0 is 1. So we have a pi by 4 plus pi by 4. So you can see basically it is satisfying because it's equal to pi by 2. If I substitute x as 0 over here, this becomes 0. Y as 1, this becomes tan inverse of e. But that is not equal to pi by 2 because if I take tan inverse on the other side, tan pi by 2, I know it's infinite, but on this side we are getting the value e. So this is not applicable because I'm getting tan inverse e is pi by 2, which is not true. Next, going on to the same thing, tan inverse of 0, I know it's basically 0. Tan inverse of e is equal to pi by 4. That's again not true because tan inverse of e is some value which I don't know exactly, but that is not going to be pi by 4 because if I take tan inverse on the other side, I will be getting e is equal to tan pi by 4. And tan pi by 4, we know it is 1. So that is why e will not have the value 1. So that is why this is also a wrong option. Moving ahead, we have tan inverse y plus tan inverse e raised to x. So we have already seen that it is nothing but pi by 4 plus pi by 4, which is giving you pi by 2. So this option is also not satisfying the given condition. So only option is A. Moving to the next one, using the same logic, we can apply the same thing over here. But this particular logic becomes redundant, or it cannot be basically helping us if two of the options are satisfying the given solution. So let's see in this whether it is in that category or not. So again we have y is 1 and x is 0. Let us substitute in this equation. So we have y as 1, log 1 is 0, and e raised to 0 is 1, cos square 0 is also 1. So we are getting this as 1, this as 0, and this is 1. So 1 plus 1 is 2, which is true. So we can mark this as one of the option. Let's go ahead. Log of 2, so this becomes log 2. This becomes 1. So we know that log 2 plus 1 is not basically equal to 1. So this particular option is wrong. So we can just ignore that thing. Next, going ahead, we have y as 1. Log of this y is basically equal to 0. So we have 1 on this side, and you can see 1 on this side also. So you can see this is also one of the options which can be valid. Moving ahead to this one, If I substitute y is equal to 1 in this, it becomes 2. If I substitute x is equal to 0 in this becomes 1. So 2 plus 1 is 3. So obviously this is wrong. So you can see we have eliminated two options, but two options are still remaining. So now how to basically check whether the given thing, which of the options is right? What you can do is simply, since the differential equation is already given to us, we can find directly the derivative of this options. So if I find the options, if I find the derivative of the options, what you can see is, if I have this derivative, so it's nothing but, let's check for C. The derivative of y is dy by dx plus log y is 1 by y dy by dx is equal to, on this side we are having e raised to x, so e raised to x remains as it is, plus it's going to be e raised to x as it is and cos square's derivative, which is nothing but minus 2 cos x sin x, which I can write it as minus sin 2x. Now let's see whether this thing is present in this equation or not. So we need a dy term and a dx term separately. So let's do that thing. So dx goes that side. We don't have any 1 by y term, so we can simply multiply by y, and we can take this e raised to x common and take it over here. So I'll be getting e raised to minus x on this side. Since we have taken dy common and we have multiplied with y, which this becomes y plus 1 dy is equal to, on that side we'll be having y into cos square x minus sin 2x dx. But as you can see, this term is also on the LHS with a positive sign, which we cannot get it from C option. So your option, basically the right option, is nothing but A. So by using such tricks, if you don't know the concept of this differential equation, how to solve it, you can use this basic concept wherein you can quickly find the particular solution. So as you know, we have started with this new segment wherein we ask you a couple of questions so that you can just check your understanding on the particular topic. The solution for this will be provided in the upcoming video. So these are the questions for this particular video, wherein the first one is asking you the degree of the differential equation which will satisfy this equation. Next one, it is asking you to find the differential equation for a family of curves which the length of the normal is equal to a constant k. And the next one is basically asking you to solve the equation. So these are the questions for your differential equation. The solution for this will be provided in the next video, which is also going to be related to differential equation. So thank you guys for watching our video. Please let us know in the comment section how do you find these videos. Do subscribe to our channel, do share our videos with your friends, and do like our videos. The liking and the sharing of the videos help us make more content for you. We'll be starting with the physics section of Mhtcet, so please stay tuned for that also. And for regular updates, hit the bell icon. So keep learning, keep watching, and happy learning. Bye.